On the 16th of July, in a hall in Shanghai, a curtain lifted on a wall of matte black cabinets stretching 12 meters across the floor. 160 of them. 1,000 square meters of machine. Inside sat 8,192 processors, and not one of them was made by an American company. This is Huawei's Atlas 950 SuperPod. The chip at the heart of it was designed in Shenzhen, etched in Shanghai, and fitted with memory. Huawei had to invent itself, because by then nobody on Earth was allowed to sell it any. That was 3 weeks ago. This month, the same chip goes live on Huawei's cloud. The numbers are published. The machine is real. And here is what almost nobody covering it has said out loud. None of this is actually about the chip. China did not spend 6 years under sanctions to build a better processor. They built something else entirely. And by the end of this, you will understand what it is and why it frightens Washington far more than any piece of silicon ever could. Start with the silicon. To print a modern AI chip, you need extreme ultraviolet lithography. One company on the planet builds those machines. Since 2019, China has been forbidden from buying a single one. Not restricted, forbidden. So Huawei cheated the clock. Teardown analysts later found that essentially every Ascend chip they cracked open contained dies made not in China but at TSMC in Taiwan. Roughly 2.9 million of them routed through a Cayman Islands shell company. TSMC was fined $1 billion. And by early 2026, that stockpile was gone. From that moment, every Ascend chip had to come out of a Chinese fab on Chinese wafers, using machines built for a far coarser generation of silicon. SMIC did it anyway. They took deep ultraviolet immersion scanners, tools never designed for this, and ran the same wafer through them 4, 5, 6 times, each pass laying down a fraction of the pattern. Think of printing a magazine cover on a low-resolution printer by feeding the same sheet through repeatedly, building the image in layers. Except every pass has to line up to within a few atoms, or the entire wafer is scrap. The result launched on the 20th of March, 2026. The Ascend 950. Roughly 1.56 petaflops at FP4. About 2.8 times the throughput of NVIDIA's H20, which was the most capable chip NVIDIA was legally permitted to sell inside China. Then the memory problem. Nobody would supply Huawei high-bandwidth memory, so Huawei built its own and gave it names nobody outside China had heard of: HYBE-L and HiZQ. The training variant carries 144 gigabytes running at 4 terabytes per second, with 2.5 times the interconnect of the chip it replaced. $16,000 a card. 750,000 units targeted this year. ByteDance alone committed $5.5 billion, roughly half of Huawei's entire annual output, bought by a single customer. But here's what nobody says about that manufacturing process. At the next node down, yields sit near 20%. 4 out of every 5 chips die on the line. That should make this program economically impossible. It doesn't, because the chip was never the point. The real prize isn't the silicon at all. And that is exactly why Huawei stopped trying to win the fight everyone assumed they were fighting. Measured chip against chip, Huawei loses. Industry analysts place the Ascend 950 somewhere in the neighborhood of NVIDIA's H200. Competitive, not superior. And for the last 20 years, that verdict has been the end of the conversation. Because the entire semiconductor industry is built on a single article of faith: the fastest chip wins. Huawei simply refused to accept the terms. They changed the unit of competition. Their interconnect protocol, Unified Bus, lashes 8,192 Ascend chips together into one machine with one shared memory address space, behaving not as a network of computers, but as a single computer. That is the Atlas 950 SuperPod. 128 compute cabinets, 32 communications cabinets, roughly 1,000 square meters of floor, about a quarter of an American football field wall-to-wall with silicon. Now the comparison that matters. NVIDIA's flagship rack-scale system connects 144 graphics processors. Huawei's connects 8,192. That is 56.8 times the chip count, 6.7 times the total compute, 15 times the memory at 1,152 terabytes, and 62 times the interconnect bandwidth at 16.3 petabytes per second. Picture it this way. NVIDIA builds the fastest engine on Earth and puts it in one car. Huawei builds a slower engine, builds 8,000 of them, and bolts them into a single vehicle that somehow still steers like one car. The breakthrough was never the engine. It was the drive shaft. And the drive shaft is light. The whole fabric is optical, over 4,000 transceivers in the demonstration unit alone, carrying signals more than 200 meters inside the building, on links Huawei claims are 100 times more reliable than the conventional approach. Across all 8,000 chips, they claim 95% compute efficiency, meaning almost nothing is lost to coordination. 8 exaflops, nearly 5 million tokens per second in training, close to 20 million in inference. 17 and 26 times the system it replaces. Then, in April, DeepSeek released a 1.6 trillion parameter model and gave Huawei's chips optimization access from day zero. NVIDIA and AMD reportedly did not get that access. A Chinese lab handed a Chinese chipmaker a head start over the 2 American companies that used to define the field. And this is the part I've been building toward. The single fact that reframes everything you have just heard. Because that machine carries a cost, Huawei never once tried to hide it, and that cost is not a flaw in the plan. It is the plan, which is why the number that decides this entire story isn't measured in flops at all. It's measured in megawatts. Analysts estimate a single Atlas 950 SuperPod draws somewhere between 18 and 22 megawatts continuously. Enough electricity to run a small town, consumed by one machine standing in one room. NVIDIA's system does more work per watt. Huawei's engineers know that. Beijing knows that. They chose it anyway, on purpose. And here is the reframe this whole video has been walking toward. This was never a semiconductor strategy. It is an energy strategy wearing a semiconductor costume. Consider what China actually has. In 2024 alone, it added 543 gigawatts of generating capacity, more than the United States has added in its entire history. It has built more than 1.8 terawatts of renewables and threaded the output through 45 ultra-high voltage transmission projects spanning over 40,000 kilometers. By 2030, it is projected to hold roughly 400 gigawatts of spare capacity, about triple the expected demand of every data center in the country. Then look at the incentive. Gansu, Guizhou, and Inner Mongolia cut data center power bills by as much as half, but only for facilities running domestic chips. The inefficiency isn't tolerated. It's subsidized. Now, hold that against the other side of the Pacific. Goldman Sachs projects that under rapid data center growth, America's effective reserve power margin could fall below 15% by 2030, the threshold the industry treats as the edge of reliability. A modular Huawei data center goes up in 6 months. The American equivalent takes at least a year. So here is what the export controls actually did. They were built on one assumption, that computing power is bottlenecked by silicon. China rebuilt its entire stack so that computing power is bottlenecked by electricity instead, and electricity is the one input China has in surplus and America does not. Then Beijing sealed the door behind it. A drafted plan worth 2 trillion yuan, roughly $295 billion over 5 years, mandating that at least 80% of the technology, chips included, be domestic. China Mobile and China Telecom operating the sites, wired into one national computing grid by 2028. Fold in the power upgrades, and the figure passes $700 billion. The results are already on the books. NVIDIA went from about 95% of the Chinese market to 0 Hopper shipments in the quarter ending April 2026. Bernstein projects it holds around 8% this year. Jensen Huang's own word for what happened was conceded. So what does all of this actually mean? It means the controls worked exactly as designed and produced precisely the opposite of the intended result. 6 years of denial did not prevent a Chinese AI chip industry. It forced one into existence, and then taught it to root around every choke point at once. Cut off from the lithography, they multi-patterned. Cut off from the memory, they built their own. Cut off from the per-chip crown, they stopped competing for it and changed what a computer is. Washington's alarm is on the record. Commerce declared that using an Ascend chip anywhere on Earth violates American export law. Congress moved the AIOVERWATCH Act out of committee 42 votes to 2. Analysts warned the export cap alone could raise China's domestic AI compute by 250%. Watch what happens next. In the fourth quarter, Huawei ships the supercluster, 64 of those machines, more than 520,000 chips, 524 exaflops. Watch whether Chinese memory production clears its yield problem, because memory, not logic, is the real ceiling now. America spent 6 years guarding the chip. China spent 6 years building everything the chip plugs into.